The next kind of series I want to look at is something known as a telescoping series. It's a neat effect. It's not super common on the AP exam, but it does happen from time to time. It's definitely discussed in college courses, okay? So here's an example of a telescoping series. And if you just start substituting in and listing terms, it's very likely you're not going to notice anything, okay? In this particular case, if I sub in 1, that'd be 1 times 2. You'd get a half as the first term. If you put in 2, you get 2 times 3, which is 6. If you put in 3, you get 3 times 4, which is 12. If you put in 4, you'd end up getting 1/20th, and so on. You might be able to see that the nth term test here, the individual terms are going to approach 0, so we cannot show that it diverges by the nth term test. And basically, the nth term test just ends up being inconclusive. The follow-up then is, well, okay, what else is going on here? It's not a geometric series, okay? And because it's not geometric, we can't just find an R value there and say if it's convergent or divergent based on that, all right? So the question is, how does this work? Well, not much you can see from there, okay? The individual terms are getting smaller, but we've seen geometric series that converge where the terms get smaller. We've seen the harmonic where the terms get smaller and it diverges. And so, where does this fall in the grand scheme of things, okay? Sometimes writing your series in a different form can give you an insight that just listing terms doesn't give you, okay? There's just all kinds of basically tricks in your toolbox, and this is one of the ones you want to try. Notice that this could be written using partial fractions, okay? If you remember with partial fractions, you've got 1 over n times n plus 1 would be equal to something over n plus something over n plus 1, okay? And if you use, for example, the Heaviside method, you might remember whatever makes this 0, you could substitute in here to find a. So that would be 0 in this case. 1 over 0 plus 1 is 1, that's your a term, okay? And then whatever makes your other denominator 0 is what you would substitute in for that. You can cover it up. That would be -1. So I've subbed -1 in here, and I get 1 over -1, which gives me a b-value of -1. Okay, check this out. This is fascinating. I don't know how anybody ever stumbled on this, but it's brilliant. So if you rewrite it as 1 over n plus -1 over n plus 1, okay, I'm going to start listing terms, and I want you to see what happens when I start listing terms. This is really cool, okay? So if I substitute in 1 here, I'm going to get 1 over 1, which is 1. If I sub in 1 here, I'm going to get 2, I'm going to get -1/2, okay? N becomes 2. I substitute 2 in, I get a half, okay, positive a half. I sub in 2 here, I get -1/3, okay? I make n 3, I get positive 1/3, and then I get -1/4, okay? And now hopefully you can see what's going on here. I've got a positive -1/2, a positive and -1/3, okay? I'm going to end up getting another positive 1/4, and this is just going to continue, okay? And what's going to happen is all of these terms in the middle, except for, like for example, if I sub 4 in here, I would get -1/5, okay? For whatever value of n you substitute into this, and however far you take it out, everything is going to cancel except for the first term and the last term, okay? The reason this is called a telescoping series, you can think about opening a telescope up and then you shut the telescope. What do you have left? You have the eyepiece at one end and you have the end piece with the lens on the other end, and all of that stuff in the middle goes away, okay? This stuff all knocks out, okay? Now, this goes to infinity though, so this is going to continue, but it's going to continue out to -1 over n plus 1, okay? But think about it, as n goes to infinity, that's going to give you a very large denominator. That last term is going to approach 0. And so we can say that this overall sum, as you extend it out farther and farther and farther, the overall sum is just going to equal the first term plus whatever the last term is approaching. In this particular case, 1 plus 0 is going to approach a sum of 1. This is a convergent telescoping series. Okay, and again, I would not have known it the way it was originally written. I had to take that and I had to break it up using partial fractions to be able to see that. But a fascinating concept, that's the telescoping series. And of course, again, any multiples of the telescoping series also would be convergent. So if I took this whole series and multiplied by 5, it would approach a sum of 5. Okay? This is another rare case where you can actually find the sum, which again is going to be relatively rare in most of the convergent series that we're going to work with. We're going to be able to find out that they're convergent in most cases, but not necessarily that what the actual sum is. So this is a rare case where we see that. So that is the telescoping series.